Good afternoon and welcome to our second project show for today. The team from Tallinn University of Technology will tell you about two smart lunar clothing concepts that are meant to improve the life of astronauts inside the moon habitat. If you would like to learn more about the project, please use our YouTube chat to submit your questions to the team, and the students will be happy to address them after their presentation. Thank you very much for joining us today, and now I'm happy to give the word to the team.
Good afternoon, everyone, and welcome to our project show. My name is Harm. I'm the project lead of Team 12 Smart Lunar Clothing, and today I will be presenting with Robert. So for the past year, we have been working on smart integrated wearable technology for astronauts inside the moon base. Our team consists of 7 students from 4 different countries, and we all study design and technology futures at Tallinn University of Technology in Estonia. For the past 2 semesters, we've been researching the topic of smart clothing on a moon base. Have you ever considered what it would be like to live on the moon? What things would be different and what kind of challenges come up in daily life? Maybe you know very well how challenging it can be, or maybe you never gave it much thought. And that was definitely the case for us when we started out. None of us knew much about space, and definitely not about daily life on a hypothetical moon base. So when we started, we felt a little bit upside down. Our project started with the very open question, how can we improve the daily life of astronauts on the moon using smart clothing? We started out as 2 teams, and we both started with researching this topic, finding a problem, finding something that we could solve, and developing a concept for that. So, of course, during our research, we quickly found out that living on the moon is a very serious challenge. You're dealing with low gravity, which is not good for your body, very limited amounts of water, and huge amounts of radiation. For that reason, the base will most likely be underground, which means the astronauts are also dealing with an artificial day and night cycle. And on top of that, they're living in isolation, far away from Earth and from their loved ones. And also, besides those personal impacts on the astronauts, we also have to consider that the logistic systems that we're used to on Earth don't work in the same way either. Everything that's necessary for a mission needs to come up and be brought up by rocket from Earth, and waste disposal is a serious challenge as well. So while we were researching what life would be like on the moon, these are the 2 areas that caught our attention: the logistics of living on a moon base and the personal health of the astronauts. And through framing our problems through smart clothing, we arrived at these 2 specific topics: clothing management and monitoring of vital signs. So clothing management, or clothing waste, is maybe not the first thing you would think of when you're considering the challenges of living in space, but it's definitely something tricky. There are currently no good feasible ways to wash clothing in space due to the low gravity or even zero gravity on the International Space Station and the scarcity of water. That means that clothes are worn for a couple of days, after which they're discarded. On the International Space Station, they are simply shot into space to burn up, but that will not be as easy on the moon. And besides that, it's a very wasteful process, resulting in about 200 kilos of clothing per person every year. And as we discussed before, there are a bunch of different factors in space that have a negative effect on your health. To combat this as much as possible, astronauts require a large amount of high-quality sleep and exercise to stay fit. But we also know from studies on the International Space Station that this is a serious challenge, and astronauts often don't meet those goals. So for long-term missions, we will need to make sure that astronauts stay fit and healthy, while also making sure that we can intervene as fast as possible when we see negative trends. To do this, we gather and analyze data under sleep and exercise. This great data is great for personal use, but it can also be pulled together and analyzed to study effects of long-term exposure to low gravity on the human body. But the monitoring process can be very unpleasant for astronauts. It usually involves a bunch of machines that need to be connected to their bodies, which can result in feeling like a guinea pig. And of course, this is something we want to avoid, especially for long-term missions. After the research phase of our project, we were left with what seemed to be some interesting problems that could be encountered on the moon base. And the next step was, of course, to transform these problems into new opportunities for exciting innovations. With this, we developed 2 concepts, and Robert will now present to you the first one, the modular shirt.
Oh, hello, I'm Robert. In our normal daily lives, we just wash our clothes when they're dirty. And what dirty means is personal and cultural. Some people will wear something once before washing it, and others might air it out and wear it again. And of course, it also depends on what you did while wearing these clothes. If you went to the gym or you were working in the garden, your clothes probably need a wash before you want to wear them again. But in a clinical environment like the moon base, the only solution, the only source of dirtiness is perspiration. And here we can make an important distinction between apocrine glands and eccrine glands. While eccrine glands only let out carbohydrates, apocrine glands also let out proteins. This combination causes the typical smell that warns us our clothes are dirty. But when we decide to dispose of a t-shirt based on this sign, the shirt is actually only 25% dirty. Based on this, we developed a modular shirt with removable sleeves and armpits. We also used a high-tech Merino wool blend that increases odor resistance and breathability, which allows the shirt to be aired out between uses without needing to be washed. If a regular t-shirt can be worn for 4 consecutive days on the ISS, our predictions are that a Merino wool shirt could be worn for at least a week. If we combine this with the modular sleeves and allowing the shirt to be aired out between uses, we can anticipate the total wearing time of 28 days, while only the sleeves will need to be cleaned or replaced. When considering that one shirt is supposed to last for 4 days of usage, it would mean that 8 shirts alone is needed for having a supply for 1 month. This would mean that 1.2 kilograms of weight is spent already on one type of shirt. And if we imagine daily life, then there's more shirts that are needed. But introducing modularity would help to reduce this weight down by 70% through using a base shirt and changeable sleeves. The base shirts get 30 years lower than the sleeves. It helps to reduce the usage down to 2 base shirts per month, with addition of 4 pairs of sleeves, ending in total weight of 350 grams per 1 month. And now Harm will talk about the second concept called mica.
Yes. So our second concept, mica, is a smart base layer undershirt with integrated sensors, which can automatically monitor astronauts and synchronize the data to a personal health dashboard. This data can be reviewed to judge health, performance, sleep quality, and keep track of workouts. Because the system is integrated in the astronaut's daily wear, they won't have to give the monitoring process a second thought. In this way, they can completely focus on their work while knowing the data will be available for them when necessary. Mica is designed to be comfortably worn for long periods of time. The sensors are integrated in the chest area, and they are powered by a small battery tucked into a pocket at the shoulder. The shirt can automatically start recording data when worn, and it can also be set to monitor during specific periods like exercise and sleep. So let's take a look at the daily life of an astronaut. During any given day, they will spend time working on research or setting up the base. They will exercise for a couple of hours. And of course, they will spend time socializing, eating, and sleeping. So the way mica fits in there is for most of the day, it can just be used to track the basics, like general movement or resting heartbeat, which is an important metric for research in low-gravity environment. During a workout, the astronaut can receive a personalized workout routine, and mica will work together with the gym equipment to collect data on the workout, like exercise types, duration, and heart rate. This data will then be used to generate better exercise routines, which will help the astronauts stay healthy. During the night, mica can be used to collect data on sleep, like sleep cycles and movement. In the morning, astronauts can review their sleep duration and quality and adjust their schedules to allow for more sleep if necessary. These solutions will help the astronauts to stay fit and healthy and keep an eye on their data over a longer period of time. Together with our partner Protex here in Tallinn, we also develop prototypes for both concepts. The modular shirt shows off its removable sleeves, while mica has real integrated sensors to showcase how the shirt works. Of course, we would have loved to showcase these on the exhibition, but sometimes things work out a bit different than planned. And as you could already see probably in the pictures, these prototypes have a pretty similar form factor. The concepts have been developed by both teams independently, but they are definitely compatible and could be turned into one comprehensive smart undershirt in the future as well. So now we will take a look at how these solutions would apply back to Earth with Robert.
So, yeah. Well, these concepts have been developed specifically for the moon base. Of course, we also see different opportunities to apply these innovations to ourselves, so back on Earth. As we mentioned before, when we decide our clothes are dirty and need to be washed is very personal and subjective. This leads us to the question of when we can objectively determine it's time to be washed. We see more and more smart materials emerge on the market that don't require as much washing as traditional materials, which is great for our water consumption. And at the same time, this will extend the lifespan of the clothes and allows us to enjoy them actually longer. Maybe in combination with modular design, we could push this even further. And wearable technology has been very rapidly developing market over the past years. But while smartwatches, bands, and rings are becoming more popular, we also see a lot of opportunities for integrated sensors in clothing. One of these would be in the healthcare system, where ease of use and seamless integration might be extra important. So while designing for a hypothetical moon base over this past year, we actually learned a lot about real life situations that affect us all. And after today's presentation, I hope you learned something new as well. Thank you very much for your attention, and we would love to answer any questions you might have.
Thank you very much for your nice presentation. And indeed, I see that we have some questions in our YouTube chat. Thank you very much, everyone, for submitting them. I have someone is writing in the chat that the astronauts already monitor the vital signs during the training, like in the ISS. So how would your project support any advantage to the already developed systems?
So one of the big improvements that we are aiming for based on the current situations is that we want to hide the monitoring process in the clothing that the astronauts would be wearing already anyways. So this would be a shirt that is something that you can just put on underneath your normal clothes, or it could even be worn solo. And all of the monitoring equipment is already integrated, which means that you never have to give it a second thought. One of the pieces of feedback that we got during the development was that the monitoring process can feel very intrusive, especially over a longer period of time, because there's always this equipment that you have to wear, or there's this sort of visibility of the monitoring process. And it feels a bit like someone is watching you. It's messing with your privacy. And this way, it's something that is autonomous and can just fade into the background, and you never have to think about it.
Thank you very much for your answer. Somebody is asking, were you guys able to build prototypes of the clothes?
Yes, we developed prototypes for both. So as you could see in the picture in the slide, we have a prototype for the modular shirt with actual removable sleeves. And for the smart base undershirt, we have a prototype with a couple of I have to say simpler sensors, prototyping sensors, but the basic functionality is there, and we can actually turn it on, run it, put code on it, and extract some data from it, which is something we would, of course, have loved to showcase on the exhibition. That was the original plan, but for now it will have to be through slides.
Indeed, it's a pity that we were not able to have the exhibition and to be able to see the prototypes that you have already managed to create. And somebody is also asking, what was the biggest challenge for you during this year, apart from the situation with the virus?
Maybe that's a fun one for Robert to answer.
Definitely, maybe the biggest challenge was the start of the project, or as we are design students with no back knowledge about moon in any given way, then just starting to learn about what the moon habitat is, what's the difference between ISS and the moon habitat, and then also managing your team at the same time to produce something what we have done so far.
Yes, and also the research question that we started with on purpose was kept very, very open. So we were basically told to do something with smart clothing on the moon base with no further details. So it was not only finding the solution, it was also finding the problem to solve first, which is, yeah, like Robert said, it's very interesting when you have no concept about what living on the moon looks like.
Thank you very much. It was indeed really great to have your team as part of the Igluna 2020 this year. And I see we have some questions from the audience that are related to some other teams from Igluna this year. So somebody is asking, have you thought about combining your concept with the idea from the Focus team from Milano? They had an idea of a UVC cleaning device. So have you thought about this idea to clean the clothes with the UV radiation?
I think that's mostly Robert's topic, but I think you considered that, didn't you, UV cleaning?
A little bit, but to be honest, I don't actually remember why we ditched it. It was so early in the process. But we wanted to do it independently in the beginning, and it stayed like that, sadly, maybe.
I think, yeah, now that at this point where we have the prototypes, we actually know what it looks like and how it works. Now it would definitely be interesting to look at what other teams have and maybe keep developing.
Thank you very much. I see somebody is asking in our YouTube chat, is it safe for the people to wear those electronics on the clothes?
Yes, it should be pretty safe. All of the electronics themselves are insulated from both sides, so they're really integrated in the clothing and they can be reached. And everything is running on such a low voltage that there shouldn't be any risk for health, even if there would be like something that would be exposed through damage.
Thank you very much. Still on the topic of the sensors inside the t-shirt, the question is it waterproof?
Yes, it actually is. It's almost surprising, but the only thing that needs to be taken out to clean is the battery. And on the other hand, the cleaning technique that we were mostly looking at, that we saw as the one possibility that might work on the moon so far, is a CO2-based dry cleaning process, if I'm not mistaken, but I think that was the case. Robert is nodding, so yes. And that using that is actually safe for the electronics because it's a non-conductive liquid and gas, which means that even with the battery inside, it would be possible to clean the shirt.
Thank you. I see that indeed you have made a lot of thoughts behind your concepts. I have another question from the audience. Again, for the sensors, will it be affected by the radiation? Have you thought about this?
That's something we haven't researched. That's a very good question.
Okay, I see. So then let's go to another question. What is the exact composition of your t-shirts?
So both t-shirts make use of merino wool because it's a very good odor-resistant material that can be worn for a longer period of time and can be aired out very well. And it doesn't really hold on to those particles that create the smell over time as much as, for example, cotton. It's also very durable. And then for the modular shirt, we have some other slightly maybe more technical materials. There's some jersey blend in there for stretchability. There's some mesh for airing out. But together with our partner Protex, we picked the materials for both shirts that would ensure the optimum quality, wearing time, and comfort.
Thank you very much. I think the next question is kind of related to it. Somebody is asking, do you think your fiber can be reused? For example, as a substrate for plants cultivation, like the fiber mentioned in the presentation from the Vigil team.
Robert, is that something you would know something about?
Yeah, well, natural fibers are known to be possible to be reused, and this is something that we have considered as well as our concept. Personally, there was a plan that we won't wash the clothes, but we will be able to send those clothes back to Earth. And I think if we take this part out of the concept and change it into that how we can use those clothes still on the moon, then this is something that we could look into later as well.
Thank you very much. I have some further questions. I think you mentioned already when you were answering the question about the most challenging aspect, you mentioned that actually to come up with the idea was one of the most challenging aspects. Could you remind us like how exactly this idea came from?
So to come to the actual sort of problem that we wanted to solve was an individual process for both of the teams. So at the start of the project, we split up the 7 people in 4 and 3, and we were both doing our research independently. And through that research, also looking for areas of opportunity where we could work. So I can say for our half of the team, we started first focusing a lot on sleep because we noticed that the effects of sleep would have a very big effect on the mood of the astronauts and the overall health. And then from focusing more on sleep, we sort of came back to focusing more on monitoring and the facilitation of sleep. And then we realized that with the same technology, we could also focus on sport and well-being, and then move to overall daily monitoring. And that's sort of how we ended up in that research question. And from there, we came with this design.
Thank you very much. And I have the last question for now that I see in the chat. What is the state of art of similar technologies?
At least for the monitoring, I think actually some of the best solutions that are out there are things you can already buy, like sort of the higher quality sports watches, sports bands, something like Apple Watch. And something that we are anticipating to happen in the next maybe 10, 20 years is that we will move from these separate devices to things that are so readily available and so easy to integrate in our clothing that we might actually be using these things before it actually reaches astronauts, simply because it will be so easily commercially available that it almost doesn't make sense not to do it. And it will be so much easier to put on a shirt when you go to the gym that's already tracking everything for you and does it at such a high quality that you can be drawing your own conclusions from it, or maybe even getting recommendations to work out better.
Thank you very much for your answer. Indeed, this is a very relevant topic that you are addressing in your project, both so space applications, but as you mentioned, also already now in the daily life, it's a very relevant topic. I do not see any further questions from the chat, but we still have quite some time, so it's your chance. Maybe if you would like to say a few words more about the project, then you can have a few minutes.
Oh, that's a good that's a good question. Robert, is there anything you would like to add about this?
It's been quite the journey since 1st of September when we started the project. I feel sad as well that we couldn't be doing it in Switzerland at the moment, but times are how they are. But I think we managed to pull it through, mainly thanks to our team lead Harm, who did an excellent job leading all this. So applause for him.
Thanks.
Thank you. Indeed, I see one more question now. If you would like to address this too, is there a winter version of your clothes?
We're in Estonia, so I think we should have it, but so far, no. They're specifically designed for climate-controlled, reasonable 23-degree moon bases so far. But maybe in the future.
I see. Thank you very much. Then I see that there are no further questions from the chat. Thank you so much. It was a very nice discussion with you. With that, I would like to conclude this session. Thank you very much, team, for the presentation, and thank you everyone for watching us. There will be a talk from our guest from ESA from AX Spaceship later today, so make sure not to miss it. Thanks again, and have a nice day. Goodbye.